In this video, we're going to talk about Euclid's Book 1, Proposition number 24, one of the most difficult ones I have ever done. And I'm going to show you just how difficult this thing can actually be. First of all, Euclid gives you a triangle, A, B, C. And then he gives you another triangle, D, E, F. Now, he says that side AC is equal to side DF. And he says that side AB is equal to DE. That's fine and dandy. But here's the problem. Side BC is not equal in length to side EF. Now he says that what you're going to do is you're going to prove that side BC is not equal in size to side EF. Okay? Now, here's how he goes about this. First of all, you have to draw all these wonderful little triangles. Alright, now we're going to do a little cheating here. I know Euclid would probably beat the tar out of me for saying all this stuff, but we're going to do a little cheating here so that you can actually draw this successfully. First of all, I personally drew side AC to be 2 inches in length. And I drew side AB to be 1 inch in length. Now we're going to use Euclid's proposition number 22 to draw another triangle called DGE. And here's how this one's going to work. We already know that side DE is 1 inch and so is AB. So what you're going to do is you're going to draw an arc way up here, 2 inches in length, and it's going to come over here. And then you're going to draw another arc, which is this, by the way, is 1.5 inches long. So we're going to draw an arc at 1.5 inches, and it's going to meet right here at point G. And when it does, you're going to draw a line from point D to point G. You're going to draw a line from point G to point E. And then you're going to draw another line from point F to point G. Now we can start our proof. First of all, we know as a given that side AB over here is exactly the same length as side DE. Now I say, oh yeah, that's 1 inch. Well, what if you weren't using 1 inch? Okay, that becomes a problem. But the thing is that side AB and side DE are exactly the same length. Side AC and side DF are exactly the same length. And because of propositions 22 and 23, side DG is the same length as side AC. Because side DG and side DF are exactly the same length. And we already said that side DF and side AC are exactly the same length. Therefore, yada 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 yada. Okay. Now, we're going to go on here. First of all, we've already established that side DG and side DF are exactly the same length. And because of that, we can also now say that angle DGF and angle DFG are exactly the same size. And we can do this by proposition number 5. Okay? Now, here we go. Now bear with me, this is a very long proof. Let's see. DFG, okay. Alright, now we have an angle. DFG is greater in size than angle EGF. Now, how do we know this? Well, DGF is bigger than EGF because EGF is contained in DGF. Okay? So, EGF here, I'll put a little star right there, is part of DGF. Okay? So, therefore, if EGF is smaller than DGF and DFG is the same size as DGF, then we can say that EGF is smaller in size than DFG. It's just the way it works. Okay? Now, because of this, we can also then say that angle EFG is bigger than angle EGF. First of all, where is EFG? EFG is bigger in size than EGF. How do we know this? Well, angle EFG is one angle, and DFG is part of EFG. Okay, EFG is a big angle, DFG is a part of EFG. Alright, now we've already said that DFG and DGF are the same size. So, EFG is bigger than DGF, and it's also bigger than DFG. Alright, and since we've already established that EGF is smaller than DGF, and it's also smaller than DFG, then we can say that EFG is bigger than EGF. Whew. I know that's a lot to absorb. Okay, now, because of proposition number 19, we can also then say that the length of EG is bigger than the length of EF. And because of that, we can also then say, because the length of BC is equal in size to EG, then we can say that BG is bigger than EF. And that's your proof. What a long proof, huh? I will tell you more in a future video, so stay tuned.